In this section, we'll look at more detail in database management systems and how they relate to GIS. Keep in mind that you're working in a tabular data environment when you're working with GIS data. This means that you've got rows, which are typically features, and columns, which are typically called fields in ArcGIS, and which represent the attributes of the data that you're working with. A database is a collection of tables designed for efficient retrieval and use. Overall, database management systems are systems used to store, update, and query non-geographic, tabular data databases. Database management systems contain and manage many databases of different kinds. Only a GIS database system manages spatial data. And the critical difference here is that a GIS database system is able to integrate location-specific information into the analysis and to deal with spatial data related to location. A database is typically made up of rows, which are the records of the entity or features. Columns are the attributes. For geographic data, rows always represent a geographic entity or feature. That might be a point, such as a well, or a stop sign, or a light pole, or it could be a line, such as a roadway or a stream, or it could be a polygon, like the boundary of a city, or a census tract, or a state. A database management system allows users to store, retrieve, and query data from many different spreadsheets. In other words, you have the ability to bring together data from more than one spreadsheet at a time and interact with it, display it, and analyze it in the GIS. In order to do this, the tables must be related in some way. They need to have a unique identifier that operates as a common field. A database management system does not manage the spatial information associated with the features. So, for example, here we have two different examples of population data. One is from 1980 and one is from 1990, and this is for counties in Pennsylvania. So if you wanted to use the data from the 1980 table and the 1990 table together in order to calculate population change, you would need to do that by, in some way, getting these two tables to be able to be linked together so the data can be recognized. They may be related through a database management system because they share a FIPS code. A FIPS code is a Federal Information Processing Standard which serves as the key, and this is used to associate the individual records in the two tables. The result of this is that you effectively combine them into a single new table in order to deal with the data all at one time. Both tables may be merged into one. New data may be created from data in each table, such as the population change from 1980 to 1990, and this is the resulting table. The FIPS code was used to essentially get the two tables to communicate with one another and to merge into a single table. Many of the tasks related to working with spatial data will be done through using queries, and the query is a question that is addressed to the database through the database management system. Another major feature of database management systems is that they provide a means for managing and securing data. A database administrator then may act as a central figure to address the data, update data, maintain the data, set up permissions and file protection, set up permissions that allow people to edit and work with the data, as well as that may prevent override of data when people have used it for various purposes. There are some basic set operations that are often used in queries. These include three dominant processes: unions, intersections, and difference. First of all, we'll look at union. Next is union, which creates a single file that includes all data from each file without repetition. For example, you might want to combine the total territory of the range of two species from two separate data sets. So here's an example where union would create a single file. On the left you have a map of the territory of the coyote, and on the right the red fox, and then you could put the two together in a single data set that would make a map that would show various factors. You might want to show overlapping territories, you might want to show total territory covered by each species. Intersection produces a data file containing only the records that are represented in all files, that are present in all files. so the area where both animals may compete for food or where they overlap in territory. Difference produces outputs that eliminate records that appear in both original files. The use of this would be to identify places in which predation is lower and the stress of competition is less. And finally, it's important to reinforce the concept of and the importance of the key in a database. So the key allows the database system to relate separate files, such as, for example, the FIPS code, which served as a key in the example we saw earlier. Relational databases contain numerous files that may share one or more keys. Relational database management systems enable users to produce information from relational databases. This is very important in GIS because you'll see many examples where you use the concept of relational databases in different ways. So an example would be that you may want to use data on species and aggregate it to watersheds. Then the watershed specification could act as the geographic key for connecting two sets of data. Next, we'll get into some of the specifics of how we actually use these keys in relational databases and how they're integrated through merging and joining tables in ArcGIS. That's it for these slides for this set.